Hello everybody and good morning. Thank you for joining me for another Sprinkler Talk today. Today is episode number 32. It's the penultimate one for this year. And this is going to be about sprinkler signaling and monitoring of sprinklers. Signaling and monitoring of sprinkler systems. I should say part 1 on the screen, apologies. Yeah, part 2 is going to be next week. So we've got 2 weeks of signaling and monitoring of sprinkler systems. As I say, yeah, correction to what's on the screen. This is part number 1. So as is normal, let's start off with looking at kind of a definition of what we're actually talking about in terms of monitoring. In the US, they call it supervising, but yeah, same thing, monitoring and supervising. My definition is to know the status of key parts, components or functions of a sprinkler system to better sure it is ready to be called upon in the event of a fire. If it's in good working order, everything's working, we've got a panel of green lights, green for go, everything is working. So our monitoring or supervising systems allow us to do that. Annex H of BSCN 12845 is entitled Sprinkler Systems Monitoring. I would say it should be Sprinkler System Monitoring, where it has, I've taken a quote there from that annex. The aim of monitoring sprinkler systems is to ensure the continuous operability of the main functions of the system, i.e. those whose failure might impair the correct automatic operation of the system in case of fire, and raising of a supervisory alarm to allow corrective measures to be taken. Okay, so that they kind of highlighted 2 areas for sprinkler system monitoring. Okay, we need to know what might fail and obviously and deal with it. And so we got to raise a supervisory alarm, but actually correct what is wrong with the system. Okay, there's obviously tests that need to be done on a weekly, monthly, annual basis, and then we've got other sprinkler talks which talk about that. I think it's 23 and 24. So yeah, that's forms part of this kind of checking procedure. But in between that, we have our supervising or monitoring systems tell us if something is going wrong. So which particular bits need to be required and how they are to be monitored will vary across different standards, hazard class and purpose, i.e. is it property protection or life safety. So we've already had a sprinkler talk on life safety. That was sprinkler talk number 9. So there is some more details in terms of what additional things will need to be monitored as far as life safety goes. Generally speaking, the status for each item is either green, amber or red, your kind of classic traffic light symbols. Green is good, green is healthy, amber, there's a fault, and red is for fire. Or if it's not a fire, it's certainly water flow. So, it needs dealing with straight away, and say that kind of feeds into the cause and effects, which we might talk about a bit more next week. Yeah, if we get a fire signal, then other things may sort of activate around the building. May mean that doors may be going to open. Other systems for evacuating the building, etc., are all going to kind of come into play. Annex I is the next one down in the standard, and that actually talks about Type A and Type B alarms. So I tend to talk about fault and fire. So essentially, Type A is a fire and Type B is a fault. So Type A is something that's really important, needs to be dealt with straight away. B is a kind of a advisory thing. We need to get on this as soon as we can. So yeah, just bear that in mind that with 2 different languages here, fault and fire and Type B and Type A. Because there is a little bit of nuance in terms of a Type A, may not quite be a fire, It depends really what the signal is. Annex H has different sections which talk about what items require to be monitored, and that's quite a nice way of starting, kind of introducing this topic in terms of what we're actually going to be monitoring. And the standards say this is in addition to any other requirements. So as I said, it's basically saying, this isn't a complete list of what you need to do, but you need to at least do all of these. Stop valves controlling water flow to sprinklers. So any stop valve which is going to be controlling water to sprinklers should be monitored. Other critical stop valves. What that means is that other valves that are important for the sprinkler activation. So, for example, the infill to a tank may not be vital, because if you've got a full capacity tank, then you're not actually relying on the infill. But if you've got a reduced capacity tank, then the infill, any valve on the infill is going to be a critical valve. Valves that are to do with the running of the pump, for example, would be critical. So there are some other critical stop valves that need to be monitored as well. Liquid levels, so basically we're talking about water, although I suppose we're also talking about fuel and other things that we may need. But mostly when we're talking about liquid level, we're talking about is there water in the tank. Pressures, so anything that is checking pressure, so we need supply pressure, we need pressure in the sprinkler system. If we've got a dry system, then we're going to need to be checking the air pressure. So all of those need to be monitored as well. Electrical power, if we are, generally speaking, in a sprinkler system, we are relying on electrical power somewhere. If it's a town main system, then I guess arguably we're not, but most of the time we are using an electric pump. We might of course be using a diesel pump. We might be using trace heating. We might have some panels which are important. So obviously a power failure needs to be activating alarms. And finally, temperature. We don't want any water to freeze. We don't want our fire pumps to freeze up. So there are going to be sensors that are monitoring the temperature of the water in the sprinkler tank, for example, and the temperature in the pump house, which are going to alert us to any problems. And what that's really doing, essentially, is saying that the heating system has failed. But more about service and maintenance. There we are, Sprinkler Talk 23 and 24. So as I say, part of that maintenance routine is to check all of these things, but we are still monitoring them as well. A couple of other quotes here from Annex I. So Annex I is kind of going into the specifics of what each alarm needs to do. It says alarms should be connected to an alarm panel in the sprinkler control room or pump room and be transmitted onwards depending on the importance of the alarm. So again, for me, I suppose that's a little bit loose in terms of what exactly we need to do. But important alarms, I would say type A alarms, need to be passed on to other systems appropriate to the building. Alarms should be transmitted to a permanently attended location on or off the premises, and type B alarms in addition might be transmitted to a responsible person in such a way that immediate corrective action can be taken. So that's kind of interesting that even back in 2015 when this annex was first written, we had this idea of basically sending text messages. That's for me what it boils down to, is kind of having a responsible person that they're going to have a remote kind of access to these alarms. Obviously this is optional, but it is useful. Apologies if you can hear a banging noise in the background. We're having some work done at our offices. And then finally, if a direct connection to the fire brigade exists, then that transmission should be agreed with the authorities. Again, I suppose you need to just discuss that with the authorities and the fire and rescue service in terms of the appropriateness of that, for example. I think that fire and rescue service is again, I don't want to kind of speak for them, but I think they get a bit fed up with having call-outs, false alarm call-outs based on smoke detectors. We all know that smoke detectors are sensitive. So, if we burn the toast, the smoke detector goes off, and then we might get a fire and rescue service turning up unnecessarily. With a sprinkler activation, though, we can be a lot more certain, that there is a fire. So fire and rescue service, I would say, are more amenable to attending straight away if there is a sprinkler activation, not necessarily on a smoke detector activation. Okay, let's have a look at some examples of fault signals on sprinkler systems. So where would we be getting off our fault signals from? So first of all, it's monitoring the water supply pressure. That could be done with a kind of pressure transducer or with a more traditional pressure switch. A couple of examples there on the left-hand side. Another thing we need to monitor is, say, that the water in the tank liquid levels. That's often done with one of these style of sensors. So it's just a simple float. So when the water level rises, it's going to close that sensor. So that one is, I guess, normally open. So that's probably your high alarm. So when the water level goes up to high, it's going to close that circuit and send you an alarm. Obviously, high water means that we're likely to start flooding the place because the tanks are only going to take so much water and then they're going to start to overflow. Alternatively, you could have it the other way around. So the one that is on a low level is going to be normally closed, so that kind of lever is going to be in the closed position, and when the water goes down below the lowest given level, then that lever is going to swing down, it's going to open the circuit, and again would send you a signal to let you know that there is low water. Other examples of fault signals is a stop valve, isolation valve, zone valve, all pretty much the same thing. So there's an example of one there, and you can see that little sort of tail of wire coming out of the end of that gearbox. So that is for monitoring purposes. So almost all isolation valves should be in the open position at all times. You can see that this valve pictured looks to me like it's currently in the closed position, because the indicator, the yellow blob on the top, looks like it's perpendicular to the flow of water. So that will be in the closed position. But I say most of them should be in the open position. The only exception to this is the bypass line on a life safety alarm valve, which is normally closed. Other example is a trace heating controller. So our trace heating controllers look after any trace heating on the sprinkler pipework, which is a method of just giving a kind of very base amount of heat just to stop water freezing. So the controller is there to sense the ambient temperature. So let's say, for argument's sake, when the temperature drops to 5 degrees or below, then the trace heater will come on and start to just say give a little bit of heat to the pipe to stop the water freezing. And when the temperature goes above 5 degrees, then it'll switch itself off. So these controllers are going to have a fault output, and they'll be linked up again to whatever panel we've got, and that will give us a fault signal, which basically means that the trace heating is no longer working, so there is a risk of freezing. So I suppose depending on what part of the year that is, then we may need to act on that pretty sharpish. More examples of fault signals. So various pump signals. So we have the kind of pump on demand would be type B, so that the valve's closed. There's various signals that are going to be happening in and around the pump house area. which will cause fault signals. It's also going to cause fire signals as well, of course, which we'll come on to. But yeah, the pump running, for example, is a fire signal, because that's going to mean that there's an activation somewhere. The image on the right is another kind of pressure switch, and these can be used, in this example, for air supply pressure. So again, in a dry or pre-action system, we've got an air compressor, which is just topping up the system pressure in the pipework, and that is monitored by this kind of device here. So when air pressure drops or air pressure is no longer available, then that sensor will give us a fault signal. Okay, let's do fire signals now. So fire signals could be coming from our flow switches. Remember, on life safety systems, we're going to have a zone system, and each zone is going to have a flow switch. And these flow switches are detecting water flow in a little bit more localized areas around our sprinkler system. So yeah, if our flow switch activates, then we treat that as a fire signal. Similarly, on the alarm valve, so on the right hand side there, we have that's incorrectly labelled as Potter. Apologies. That should be it's a reliable alarm valve on the right hand side, and as part of that we have a flow switch, sorry, a pressure switch again. The pressure switch might be Potter to be fair, and that again will tell us that the alarm valve was tripped, the water is flowing through that alarm valve, and again that is treated as a fire signal. And there's of course other fire signals from the fire pump. So say pump running, for example, the fact that the pump is actually is moving water, that would also be a fire signal. So those are a few examples there in terms of fault signals and fire signals. I'm just going to finish up this presentation by looking at monitored lines. So I kind of a little bit nervous about doing this because this isn't my area of expertise, isn't my kind of strong point in terms of electrics, but I think I've got the hang of it. So this is an example about monitored lines. Don't get too confused about analog and addressable loops of stuff. We'll come on to that next week. This one here is just showing you an analog monitored line. So we've got one panel, we've got one wire, which is going to one device. So we're keeping it nice and simple for the time being. So in this example here, I have a monitored valve. And as we know, these monitored valves are supposed to be in the open position, generally speaking. So let's say that this monitored valve is in the open position. So you can see my switch on the left-hand side is in the open position. Now, when there's a very small amount of current, so these are called kind of volt-free lines. So yeah, just a very small amount of current which is going through this line. So that's coming round this circuit, and it will go through. So it can't go through the switch because that's open, but it'll go through both of these two resistors. So it'll go through the 5.6 and the 1 kilo ohm resistors. So the panel will see them both. So it'll see 6.6 kilo ohms of resistance. Ish, plus the resistance in the cables, I guess. So the panel will see, yeah, okay, that's what I was expecting. I was expecting to see 6.6 kilo ohms of resistance. Therefore, green light, all good. We have the valve in the correct position. If, however, the valve is closed, or so I should again point out that this is not necessarily closed. It is just not fully open. So when the valve is not fully open, well, I'll put closed just for convenience for the diagram. So when that is closed, then the switch is going to be closed. So the electricity and water, but in this case it's electricity we're talking about. Electricity is lazy. It doesn't want to go through a 5.6 kilo ohm resistor if it can help it. So when the switch is closed, the electricity can actually flow through the switch, or bypassing our 5.6k resistor. It's still got to go through our 1k resistor ohm though, so the panel will see 1 kilo ohm of resistance. And the result of that will be a fault, so an amber light, and we know that the reason is because it's going through the switch, and the reason the switch is closed is because the valve is closed. So that will give us a valve fault on the panel. In this instance here, we've got a short in the circuit. Okay, so it might be a wiring issue. It might be that the cables are damaged in some way. So here you can see the cable is kind of pinched in the middle. The resistor on the left-hand side, I should say, is called an end-of-line resistor, and based on its name, it is at the end of the line. So any damage in the middle of the cable, so anywhere kind of between the panel and the item, any kind of damage there may well result in a short circuit. So in this instance here, I haven't changed my, I've got 370 kilo ohms here now, because I was in a bit of a rush for these slides. So in this instance here, it doesn't go through our 370 kilo ohm resistor, which it now is, but yeah, the large resistor anyway, just an example. It doesn't go through there because again it's lazy. It can take a shortcut, like a short circuit, and it will just go through the 1 kilo ohm and then back to the front there. So in that instance, the panel will see 1 kilo ohm resistance, and it will be a short. When the circuit is broken, so actually get a broken cable here, then of course there's no resistance at all. So the panel will just register 0 ohms of resistance, and we get another amber result, and we have, it could be a loop or power fault. That is if the item is powered. So most of the items aren't powered. So yeah, if it is a powered item, then obviously it's not going to get its power, so that it can be used for that situation as well. But yeah, I would say that this was kind of a loop fault or open circuit, if you like. So the panel is going to see 0 ohms of resistance, and again will cause a fault. So that's an example there about how monitored lines work. By using resistors, we can tell more things. That's the point of these kind of monitored lines. If we just had 2 wires, then it would either be on or off. Whereas if we add in resistors into it, we can actually know a bit more kind of what the problem is. Is it a wiring issue, or is it the fact that the item is not doing what it's supposed to do? So that's, yeah, a little bit about how those monitored lines work. Okay, that's it for today. So next week we're going to be doing signalling and monitoring part 2. We'll be looking at analog and addressable devices. We'll be looking at different panels. We'll be looking at our zone check addressable system, which is to do with monitoring of sprinkler systems, and also does testing of the flow switches as well. So I'll be sharing kind of a little bit more about how that works and what advantages that brings. So yeah, hope you can join me next week. Hope you found that useful. And yeah, again, nice to hear your comments on sprinklertalk@projectfire.co.uk. Thanks a lot for listening. Bye-bye.